speaker is Seiji Oshima. He comes from the Faculty of Medicine. The title is Prospects of Cancer Stem Cell Targeting Therapy. So please start your presentation.
Thank you for your introduction, Mr. Chairperson. My today's topic is about prospect of CSC, or cancer stem cell targeting therapy. I'd like to propose a promising new cancer treatment. But this is not the result of my research, but the reviews of my leading-edge research on CSC. Here is the outline of my presentation. First of all, I make a brief explanation about what cancer stem cell is. The next, I will explain previous studies on CSC targeting therapy. This will be followed by my suggestion on the new cancer treatment. Then I will talk about the 3 hurdles toward my suggestion. Finally, making some comments on prospect of cancer stem cell targeting therapy in the future. First, I will explain CSC briefly. Do you know iPS cells? As you know, they can differentiate into a variety kinds of cells like this. CSCs are quite similar to them in that they can produce a variety kinds of cancer cells like this. On that point, the CSCs can be symbolized as roots. I mean, if we can eliminate already differentiated cancer cells like this. However, relapse could occur in a decade or so like this, as long as CSC remain. So, however, unfortunately, normal anti-cancer drugs have targeted only normal non-cancer stem cells. This means that the relapse frequently occurs. To solve this problem, there are so many researchers seeking for targeting CSCs. Here are some CSC targeting therapy, but now I focus on the direct reprogramming. But what's direct reprogramming? As you can see on the screen, direct reprogramming is a way to change somatic cells or body cells into cells you like. This method is quite similar to iPS technology in that certain transcription factors are introduced to change the characteristic of somatic cells. Then go to previous studies. In previous studies, some researchers have succeeded in making iPS cells from cancer cells like this. Especially Professor Mori at Osaka University and his colleagues are seeking for making less malignant cells from cancer cells by using a safer method. So based on these previous studies, here comes my suggestion. The suggestion is that if direct reprogramming can be applied to CSCs, then this method will probably become novel cancer treatment like this. However, there are several hurdles toward my suggestion. The first problem is that there is a little possibility of developing cancer as in iPS cells. The second problem is that the isolation of pure CSCs from tumors is technically difficult, so it remains to be carried out. The third problem is that there is still drug delivery system. Now we cannot deliver CSC targeting drugs to all tumors. Therefore, here comes my future prospect. We have to discover characteristic CSC markers different from those of already differentiated cancer cells in order to isolate pure CSCs. Then, this will be followed by establishment of drug screening assay by finding out a CSC drug system and building up a drug delivery system, and then we can make a victory over cancer. Thank you for your attention.
Thank you very much for your presentation. So is there any question or comment?
Do you have any questions?
Also, please give your question.
Thank you very much for your nice talk. So you already made some suggestion or some roadmap for your future experience. So if you have any idea for your future experience or future design of your study, so could you tell me?
My future prospect.
Yes, future prospect, especially for your experiment.
Your experiment.
Yes.
My future prospect is to accomplish this technology into the clinical research, clinical situation. This is my future prospect. So we have to discuss and solve these three problems. Yes.
So I understand your suggestions. How was the experiment? Experiment.
Experiment.
Okay.
Okay.
So how, which cell are you going to use or how to introduce some DNA or something into cell?
Okay. This method is quite similar IPS technology. We can introduce transcription factors. Transcription factors into the cancer stem cells. So this is the outline. Is it okay?
Yes, thank you.
Thank you. Is there any other question or comment? Or please, to the mic and give your question.
Thank you for your remark. And my question is about the hurdles toward your suggestion about the third one,
Okay.
drug delivery system.
Yes.
Your suggestion is based on the same concept of iPS cell made by Professor Mr. Yamanaka, Dr. Yamanaka, but this technology is taken in the laboratory maybe now,
Yes.
but if you want to achieve your suggestion, maybe you have to use the drug delivery system. But how by this using drug delivery system we can achieve the same situation of in the laboratory? Please explain if you have some idea about this.
Nowadays, the mouse model can be used to make an experiment. So we can try in the mouse model. We can we can make an experiment on drug delivery situation.
Thank you. We still have enough. Oh, please. Please give the mic to the teacher. Stop. Maybe you can give your question after this.
Thank you very much. My question is very short.
Yes.
Are you the first grade students undergraduate?
Yes.
Really?
Yes.
And did you read the papers? You showed some papers, the research papers published in some research journal. Yeah. Some journal. Did you read it?
Yes.
Really?
So I'm very interested in the biology of cancer, so I read it.
I'm so surprised. I love it. Thank you.
Thank you. So please give your question.
Thank you for your presentation. Could you tell me the one example to detect the CSC? Sorry? Yeah, to detect the CSC, cancer stem cells. Tell me the one example.
Okay. The cancer stem cells have, generally, cancer stem cells have the characteristic cell markers on the membrane of cells.
Yeah.
So we can recognize the difference between cancer stem cell and non-cancer stem cell.
too. So I'm afraid we don't have enough time for another question. So thank you very much for your presentation.